Yeah, good afternoon, all. Swapnil, sir, can we start a session now?
Yes, we can start.
Yeah, just I'll. Good afternoon to all the participants. I again welcome you back after a lunch, after your lunch, to session number 3 of day 1 of this short-term training program that is sponsored by AICTE ISTE on the topic of energy conservation and energy management. Dear participants, today we have with us a very distinguished speaker, Dr. Swapnil Dharaskar, sir. He is an associate professor and head of Chemical Engineering Department, School of Technology at Pandit Deendayal Energy University, Gandhinagar. His research interests are CO2 separations, deep eutectic solutions, solvents, ionic liquids, desulfurization process, nanotechnology, and wastewater treatment. He has over 10 years of teaching and research experience. He has completed many quality projects under different government funding agencies. He is currently the main PI of DST-sponsored project on CO2 separation under the Mission Innovation Carbon Capture Scheme worth 60 lakhs. He has published more than 55 research papers in reputed international journals, supervised 7 PhDs, out of which 2 are awarded and 5 are ongoing, and 20 MTech students under his guidance. He is a fellow of various professional bodies like Indian Institute of Chemical Engineers, American Institute of Chemical Engineers, American Chemical Society, International Water Association, IEI, ISTE, ISRD, International Association of Nanotechnology, etc. He is in the editorial board of board member of many international journals. He is an active reviewer of several highly reputed international SCI, SCIE journals. He has been the recipient of several professional awards. So on behalf of the organizing team and all the participants, I wholeheartedly welcome you, sir, and I request you to enlighten us with your knowledge and experience. Please, sir.
Sure. Thank you, Dr. Anurag Emmanuel, for a wonderful introduction. So I just want to ensure first my slides are, working and visible to all of you.
Yes, sir. Your slides are visible. Your screen is visible. Yeah, you have not probably. It's not on the slideshow mode.
Yes. Okay, fine. So now.
No, not as yet. Probably there's a delay or there's a lag.
No, just give it a minute only. Yeah.
Yeah.
Yes, now.
Yes, sir. We can see your screen. We can see Chemical Engineering Department.
Now you can see my second slide.
Yes, we can see your screen, but probably you're going. We can. The slides are also changing, but it's not on the slideshow mode. That's what I'm trying to tell you. Probably, sir, what you do is you present your screen,
yes,
your entire screen.
Yeah, that I will
and
do.
Then, yeah, and then do the click on slideshow.
Yeah. That I will do. Now, yeah, Dr. Anurag, please ensure now.
Yes. Now we can see. Yes.
Thank you. So once again, thank you, Dr. Anurag, and the team member of the institute to invite me for this particular, AICT sponsored STTP on energy conservation and the energy management. So earlier I decided to deliver the talk on the energy efficient separation processes for the CO2 capture or the separation, but I just little bit slightly tuned my change my topic that I just want to give you the insight on energy efficient separation process for environmental sustainability. So first of all, I just want to, as introduced by Dr. Anurag, I'm a Dr. Swapnil Dharaskar, currently working as Associate Professor and Head in Department of Chemical Engineering at School of Technology, Pandit Deendayal University. And I'm very happy to deliver my talk in front of these all knowledgeable gentlemen, and many of you are working on the various positions in the academia and the industry as well. So really great to see all of you on this particular forum. And it's a wonderful opportunity for me to deliver talk in front of all you knowledgeable eminent experts and all. So basically, as far as first slide is concerned, I just want to highlight that I'm working in the area of various, specifically in the area of green chemistry, under which I'm working in the area of nanomaterial study, ionic liquids, and CO2 capture study. Recently, we have received, not recently, a couple of years before, we have received 2 mega projects in our department under the scheme of Mission Carbon Capture Innovation Challenge. So I got one project worth rupees 60 lakhs, and I'm working on that particular project to utilize the to identify the best suitable membrane, ionic liquid separate membrane for the CO2 separation efficiency. And as Dr. Anurag told me that in the first lot, Dr. Nitin Lapshetwar sir already delivered a talk on the separations and other issues. So I don't want to go much deeper, but I just want to give you the overview about all these processes and all. But before that, I just want to introduce the team members of my research. Currently, some of the team members from the European side and then South Korean sides are involved in our project, and along with the industrial partner from the Indian side as well. So Professor Mika Silampa, he is currently working as the director of Department of Green Chemistry, Lapland University of Technology, Mikkeli, Finland, under whom I have done my postdoctoral study as well. Then Professor Chang Kyu, he's the eminent professor and expertise in the field of modeling and simulation, specifically in the environmental engineering and other sectors. So he is from King University. And Dr. T.C. Gupta, he's a senior vice president from quality R&D department of Apar Industry Private Limited, Mumbai. So these are the members, key members to work along with me in my Mission Carbon Capture Innovation project. So now to begin with, I just want to give you some highlight about CO2. Basically, all of you know that because currently we are facing lots of problem in terms of the climate change and all. If you look into the outside weather right now, we can see how the weather is. Even though since last 3 to 4 days we have not seen the sun also. So basically, this is just happening because of the climate change, and many of you are already expertise in this field. But I just want to give you some glimpse about the CO2, why there is need to capture or separate or utilize the CO2. I don't want to go into much deeper because my role and my job is to just give the idea about the separation for the CO2 processes, not for capture and utilization. So if you look into here, it's basically, if you look the statistic, then you can see, just a minute. Yeah, if you look into the statistic and then or the pre-industrialization era, that time the Earth has a natural carbon cycle that has maintained the perfect balance of carbon dioxide in the air for 6.5 lakhs years before approximately, and that time the concentration of the CO2 was around 275 parts per million. But unfortunately, currently the global average atmospheric carbon dioxide in 19 was, I have just given the figure of the 2019, was 409.8 parts per million. And again, if you are looking to the current scenario, that might be more than this one. So post-industrialization era, that's why there is need to have the CO2, we need to have a CO2 separation, and we have to understand how we can separate CO2 with the energy efficient processes. Other than that, how we can capture the CO2, and then how we can utilize the CO2 for various valuable added products. Now, what is the reason that why there is, or we can say the motivation behind to work on the CO2? Because many of us know that currently we are facing the problem of the greenhouse effect. With the rapid economic and social development, global warming caused by greenhouse gas emissions has become a worse situation in a current scenario. In the last 1 decade, we are facing lots of problems to maintain the balance of these particular things. Global warming is we are facing lots of issue in every day. Every year it's increasing, and we are facing lots of problem with these global warming and other environmental impacts. So in the field of the energy, gap resources such as natural gas, shale gas, biogas, syngas, and other contains certain amount of CO2, which has an impurity then that decrease the heating value and quality of gases. That's the second point where we got motivated to work in the field of the CO2. And third one, based on this, we have decided to go for the CO2 separation is one of the become a most important option for greenhouse gas control and energy resource upgrading and purification. That's why we decided to identify the best suitable process for energy efficient CO2 separation. Now, as far as the need of the study is concerned, as I mentioned you, emissions of greenhouse gases will increase the average global temperature by 1.1 to 6.4 degrees Celsius by the end of the 21st century. And a global warming of more than 2 degrees Celsius increase in the global average temperature will lead to serious consequences in terms of environmental causes and the serious concerns in terms of the environmental, cause and pollutions. And then global greenhouse gas emissions should be reduced by 50 to 80% by 2050 with the source of IPCC, means it's a pollution control board from International Pollution Control Board, or you can say Indian Pollution Control Board. And then to keep the temperature rise less than 2 degrees Celsius relative to pre-industrial levels, and that CO2 emissions should be reduced globally by 41 to 72% by 2050. And this is the challenge right now. Even if you look into the Niti Aayog report, they have also highlighted that we have to work on the CO2 minimization, because the adverse effects of the CO2 is really very much impactful in terms of the environmental sustainability and other issues as well. Now, basically, these are the basic background of the CO2, why we are trying to work on the CO2 separation. And as far as the objective of our study is concerned, I don't want to go into much deeper into my research area, but I just want to give you the overview about what exactly the objective of our work. Based on this, entire literature, on entire understanding, we thought we decided to work on a membrane support, liquid supported membrane, because nowadays in the market there are some commercialized membranes are available, which is useful to minimize, which is really useful to separate the CO2. But again, that particular things have some limitation. Then we decided to look into some ionic liquid supported membrane, and we identify, based on the preliminary study, we identified that some of the ionic liquid supported membrane are really promising to separate the CO2, and we are able to achieve a good separation for CO2 in terms of in comparison with the existing commercialized membrane. That's why we decided to work on this particular one, and our objective is to work on the best suitable ionic liquid supported membrane for the CO2 enhancement or CO2 separation enhancement. And that's why we are majorly focusing on the energy intensive process, which is really useful in terms of energy separations and all. Now, as far as the methodology for CO2 separation is concerned, there are various routes. You can see with this particular flow chart, you can see there are different routes. Biological route you can prefer geological route, and there is another route is a physiochemical route. Since we belong with the chemical engineering background, we decided to go for this particular route, and we identify the potential of this route very effectively. If we go for biological, there are certain pros and cons, and you guys might be aware about that facts. We have to take care of all many weather conditions and other operating parameters and all. In terms of geological route, again, we will face certain problems. But if we go with the physiochemical routes, there you can identify the different techniques like absorption, adsorption, membrane separation, and cryogenic distillation. Basically, some of my colleagues are working in the area of absorption and adsorption, but we targeted specifically in the area of membrane separation, not closely with the membrane separation, but we are trying to use a membrane, membrane support, and try to modify the membrane in support with the ionic liquids, and we are trying to produce a best possible support, which is really useful to enhance the CO2 separation from the industrial stream. And that's why we decided to work on this particular area, and this is the methodology for our ongoing research at PDU campus. Now, I just want to give you the glimpse about why we are trying to work on the membrane on gas separation processes. There are certain parameters whenever we decide to go for any sort of research or any sort of work, we always think about a few parameters, and here, based on that parameter, we can identify whatever whatever process we are preferring, that's really effective or not. So these are some parameters like cost effective, energy efficient, or and then clean energy and efficient product and services, And then the most important part is the fast separation with simplicity of operations and high space economy. And finally, that's why for all these parameters, we decided to go for membrane gas separation is very good option than other CO2 capture processes. At the current, in the current state, in our department, we have we some colleagues working on adsorption and absorption, and we have compared their results with our results. And in terms of flexibility of our research, we have identified this particular area and this particular method is really flexible in comparison with adsorption and absorption processes. But sincerely speaking, at present status, most of the industries preferring the absorption or the adsorption route for the CO2 separation. But very soon they will identify some alternatives for that processes because of the other issues and because of the good efficiency. They may go for membrane or some membrane light separation processes. Yeah. Now we decided to work on the membrane in align with the ionic liquids, since basically I did my PhD in the area of the ionic liquid and postdoc in the area of molecular simulations and the ionic liquids. So I decided to scale up this ionic liquid in support with the membrane, and that's why we decided to club both the things together and try to make such assembly which is really impactful for CO2 separation. So as I mentioned you about the membrane, similarly I just want to highlight some important facts about ionic liquids. Some of you might be aware about what exactly the ionic liquids are, and basically these are the compounds which are having the melting point 0 and below 100 degrees Celsius. And these particular ionic liquids are having a very good properties. Sometimes this ionic liquid is termed as a green solvents as well, based on some parameter, because it inhibits some green solvents properties or green properties. That's why this ionic liquid termed as a green solvent as well. So first property is high ionic conductivity. Second one is non-flammability, very less vapor pressure, non-volatile in nature, high thermostability. Because as far as the CO2 separation is concerned, we do require high thermostability. And in that case, Dr. Anurag, hope I'm audible to all of you.
Yes, sir, you're audible, sir.
Okay, fine, thank you. So these ionic liquids have a good thermostability, and this based on this thermostability, in our research, specifically for the CO2 separation, we can able to sustain the high temperature kind of things. The membrane, we can make a membrane which sustain the high temperatures, right? So, and then wide temperature range for liquid phases -40 degree to 300 degrees Celsius, non-corrosive in nature, and as I mentioned you, it inhibits the property of the green solvents, and that's why it's considered as a green material and the green green solvents as well. Now membrane, I don't want to explain much about it because many of you are already familiar with the membrane. So basically it's one kind of a barrier which allows something to pass and stop other things. Such things may be molecules, ions, and other small particles. There are two types of membrane. One is biological based membrane, or this synthetic membrane. In our case, we are trying to prefer synthetic membrane, or we are trying to prefer some supports, commercial available supports, to modify it and with support of the ionic liquids, and we are using that particular support for the enhancement of the CO2 separation. Now, the most applied membranes for the membrane gas separations are, there are two different categories of the membrane. One is organic membranes and another is inorganic membrane. Okay, so as far as the organic membranes are concerned, there are some membrane which are glassy polymers and rubbery polymers with high permeability and the low selectivity. In the similar line, inorganic membranes, which consist of metals, carbon molecule hues, carbon nanotubes, zeolites, clay, and silica. These particular membranes have low permeability but high selectivity. Our target is to go for high selectivity, and that's why we are mostly preferring the inorganic membranes for our study. Sometime in case of high permeability requirement, we go for the organic membrane. Likewise, we are doing the comparative study, which membrane is good, either organic or inorganic, and where and for which membrane we have to go for. That's why, based on either high selectivity or high permeability, we will decide which particular membrane support we have to identify for CO2 separation. These are some membrane classification. I don't want to highlight much about it because there are in membrane, it completely depends on the symmetric nature, asymmetric nature, and tubular membranes, hollow fiber membranes, flat sheet membranes, dense membrane, porous membrane. In our case, at the moment, we are working on flat sheet dense, porous, and hollow fiber membrane. So far, we are not tried with the tubular membrane. We are just going for asymmetric kind of membranes as well. So flat sheet, dense, and porous membrane. We are working identifying the CO2 separation enhancement. Now, this is the principle of the membrane separation. Just now I have highlighted the slide. It's a physical barrier from semi-permeable material that allows some components to pass through while others are held back. So this is the a membrane where I will show you the schematic of our setup. That time you will realize how this membrane act as a proper barrier. So CO2 separation using membranes. So this is the mechanism behind it. Basically, a pressure-driven process. It's a pressure-driven process where the driving force is the partial difference of the gas in the feed and the permeate, right? So the most important parameter for the gas separation processes or the membrane separation processes is the selectivity and the permeability. And based on this separation parameters, selectivity parameters or the permeability parameters, we have to select which membrane with which support is the best suitable support for the enhancement of the CO2 separation, right? So here use highly selective thin membranes and commercial membranes. There are some membranes available in the market, and right now industry prefer that membrane that is completely based on the polymer and the cellulose acetic based membrane, but they are having the selectivity something around 26 or 28. But in our case, we are getting the selectivity more than 35. That might be the one factor we can make this technique commercialized in comparison with these readily available polymer based membranes and the cellulose acetic based membrane. Now, this is something about the mechanism of the membrane separation. There are various, processes or the mechanism that comes under the category of porous and non-porous. I don't want to highlight much about it, but keep in mind one thing here: this molecular diffusion and the tension diffusion. This 2 or 3 diffusion, surface diffusion, plays a very important role in terms of separation processes for CO2. Now, this is the gas schematic of the gas permeation unit with online gas chromatogram. We are having a setup available at our campus. We procured something around 20-25 lakhs rupees setup of this gas permeation setup, where you can see now this is the entire setup of the gas permeation, where we can see we can keep the membrane. There is one membrane module. You can see here. This is the membrane module, flat sheet membrane module. We have a different types of modules to attach with here. First, we tried with flat sheet. Then we can go for hollow fiber, and then porous, and we can prepare porous and dense membrane. And then there are different types of inlets and outlets. Here you can see the mass flow controllers are there. And on another side here you can see the CO2, methane, helium gas, and this is the entire setup. Here you can see this is the actual membrane module. Here you can see this one is, but we have modified that module, and you can see the entire module, how it works. And we have the provision of the online GC, whatever gas we are passing, let's say in terms of CO2 and methane. So this particular GC will give us the idea about the composition. No, biomass, let's say biomass contains carbon dioxide and the methane. So likewise, we are maintaining the CO2 and CH4 compositions, and we are trying to identify how much in which ratio we are getting CO2 separation and methane separation. Likewise, we will do some calculations based on some correction factors, and finally we can able to look into the actual value of how much CO2 got separated and how much methane we have separated. So this is the entire setup of the gas permeation, and which is available at Department of Chemical. Here you can see there are different types of membrane modules. As I mentioned we are having different types of modules. So this is the actual image of the first flat sheet membrane module. Then how it looks like, and then how we can prepare the membrane. We do prepare membrane. We do cast membrane in our department itself. We casted so different types of membranes. Polymeric membrane, cellulosic membrane, cellulose acetic membrane, and PVDF support, PSE, PTFE kind of membrane that we cast at our laboratory. And we are also synthesized different types of novel ionic liquids to impregnate it with this membrane and finalize and make a membrane liquid supported liquid membrane, which is really applicable for enhancement for CO2 separation. So these are some routes how we can fabricate the supported ionic liquid membrane and this here you can see the various this schematic represent and gives the idea about how we can synthesize the or how we can cast the membrane. Okay, so here you can see the final cutout of the membrane for gas permeation at the various weight percentage, 5%, 10%, and 20%. So basically it's a tedious process to do, but if we have a facility available to how to cast it, then it maximum take it maximum took 8 to 10 hours to cast the actual membrane if the reagents and other things are available. Now, this is about the fabrications. Initially, I have given the idea about the setup. Okay, how this setup look like. So this is the entire CO2 permeation setup. This is the modules, and this is the fabrication of the ionic liquid supported membrane. Now I'm just trying to give you the idea about what kind of ionic liquids we have preferred earlier, and we published some sort of work based on this idea. And recently we have submitted one idea to file the patent as well. So if you look into this particular beaming means it's first of all what happened. Our target is to identify the cost-effective membrane or cost-effective ionic liquid separated membrane. Okay, so that's why we have first decided to go with imidazolium-based ionic liquids, which is very easily to synthesize, very easy to prepare, and with the help of very basic facility, you can easily synthesize this kind of compound at your own laboratory. But later on, we have decided to go for some modified class of the ionic liquid. There are different classes of the ionic liquid like thiazolium, palladium, phosphonium, and a few more. But thiazolium, since the toxicity matters, that's why we have not preferred thiazolium. But we gone for this one, palladium, and then imidazolium and phosphonium. And some of the results from phosphonium and palladium got very impressive, and that based on that we decided to go to file one patent based on that results. So these are the gas permeation results. I don't want to explain all the results in deeper, but you can see the major focus of our study is to work on the permeability and the selectivity parameters in terms of CO2 and methane compositions. Okay, so if you look into this particular one, here we have first we prepared a different weight percent of the ionic liquid supported membrane is there. So since ionic liquid is costly, then what we have done, we have just prepared a different support with some weight percent. Let's say first we have taken 5% of ionic liquid and we prepared a 5% ionic liquid supported membrane. Then we go for 10%, 20%. Likewise, we have prepared up to 20% ionic liquid supported membrane, and we have verified and done analysis for the CO2 separation for all this membrane, and the results are pretty impressive. And you can see here you can see the methane permeability versus pressure. Here you can see CO2 permeability versus pressure. And the beauty of this particular membrane is that it is able to withstand the pressure up to 5 to 7 bars. Okay, so that we have identified. Even it is useful for a prolonged temperature as well. Even though if you are continuously purging this CO2 and methane, still there is no breakage happening into the membrane, or there might be some pores got blocked. But as far as the breakage is concerned, we have not seen any breakage occur during the operation, even prolonged operation as well. And that's why we decided to go for some support which is really useful in terms of withstanding high temperature, high pressure. And that's only the uniqueness of our project, because the moment when we got the project, that time the committee just gave us one task: Swapnil, if you are capable enough to prepare such a membrane which withstand more than 5 bar pressure, that will be a good thing for us. So at this moment we have identified few supports which are really useful to withstand the pressure up to 7 to 8 bars. So this is about the CO2 methane selectivity. As I mentioned you, permeability and selectivity, these two are the important parameters, and we are extensively working on these two parameters to measure out the effectiveness in terms of the separation of the CO2. Then we go for another kind of earlier we decided to go for imidazolium. Then we shifted it from imidazolium to phosphonium bromide kind of compound. And again, we are also with the study of this phosphonium, we have really received a promising results, and that also we publish in one journal, ACS based journal, where this particular results has been claimed. And here you can see the CO2 permeability with 5 weight%, 10 weight%, and 20 weight% ionic liquid. Sometime at the initial level, we have taken the support as a plain paybags, but here we have changed the support from plain to paybags 1657. And again, we are identifying how much up to what pressure this particular membrane withstand, and we identify this particular with support of the phosphonium based ionic liquids with some membrane support. We can able to identify that particular support is withstand 8 bar pressure very easily without any breakage happening during the operation. So this is all about the permeability and the selectivity, and this is the some sort of data of CO2 and methane separation. I don't want to go into much detail about it, but the keep in mind one parameter here: the selectivity matters a lot, and selectivity and permeability. If you are able to get a good selectivity, then definitely your separation will enhance, and that's why your role is to identify the best suitable support, membrane support, in addition to the ionic liquid as well. And other than ionic liquid, you can try it with some nanofluids. Some of my researchers are working now. We are shifting from ionic liquid to the nanofluids, and we are also targeted to work on the deep iterative solvents. These two areas right now, many researchers diverted the study from the ionic liquid into the deep iterative solvents and the nanofluid kind of work specifically for the enhancement of the CO2 separation. Okay. So this is about the CO2 separation, and I hope we will take the questions at last. But this is all about the CO2 separation, the exact process for the CO2 separation. So as I mentioned, the gas separation, gas permeation membrane processes is a very efficient process for CO2 separation, and that's why we are claiming this particular process is really good in comparison with the absorption, and some other route also. Some of the researchers claim that biological route is also very effective. Obviously, it will really effective, but there are some limitations. You cannot work on the biological route, for entire year. There are some specific, you have to maintain certain conditions. Many of you, if you heard the name of the ICT have developed their own lab to establish or to generate some algal kind of things, and through algal biomass, they can they can able to capture the CO2 and separate the CO2. But here, in our case, we could not able to do that. That's why we decided to go for this particular process. And at the moment, we thought this membrane separation process with ionic liquid support is really an efficient process for the CO2 separation. So this is basically our conclusion from our group, and maybe some of you might be differed, might be have a different opinion, but this is our opinion since we have done that work with the support of the membrane and the ionic liquid. Now, I just want to highlight something in line with the nanomaterials. This is completely, whatever I mentioned so far, that is in line with ionic liquid supported membrane for CO2 separation. Now I'm just slightly changing the topic from ionic liquid supported membrane to nanomaterials, and I just give you the idea how these nanomaterials also create good impact in terms of environmental sustainability and the CO2 separation as well. Some of you might be comfortable to synthesize the nanoparticles, and many of you have the idea what exactly the pre-requirement or the prerequisite to identify the best efficient nanoparticles. Okay. So basically, if I want to identify the best efficient nanoparticle, then I must go for two parameters. One is whenever I'm planning to synthesize the nanoparticles or nanomaterial, that should have a good surface area or high surface area with good chemical reactivity. Basically, in nanoparticle synthesis, we always think about uniform size, shape, and distribution. This size and shape, these two parameters plays very important role. If you are able to maintain a proper size or uniform size and shape, then ultimately you can get a good high surface area, and that high surface area is really applicable to give you the good conversion or with good chemical reactivity for the conversion of the final product. That's why we decided to go for the nanomaterial, and we diverted some of our research from one part into the nanomaterial, and some of the researchers are working in the field of nanomaterial as well. If you classify the nanomaterials, there are different classification like 0D nanoparticles, 1D nanoparticles, 2D nanoparticles, and 3D nanoparticles. And if we quote example, so 0D nanoparticles, I mean, the common kind of nanoparticle like alumina-based nanoparticle, titanium dioxide nanoparticle, calcium oxide nanoparticle, zinc oxide nanoparticle. This you can consider as a 0D nanoparticle. 1D means one-dimensional nanoparticles where you can see carbon nanotubes and some graphene oxide or some sort of nanoparticles comes under this category. And graphene thin films or some other kind of sheets, graphene sheets, comes under the category of 2D nanoparticle. And 3D nanoparticle like polycrystals, foams, these are the 3D nanoparticles, where we can depend on size, shape, and length of the nanoparticles. In 2D, we just go for size and shape. In 1D, we go for size, and 0D maybe just simply go for only one parameter, right? These are some different types of nanoparticles family. You can see it's a layered materials. If we consider the graphene family, and then the most efficient graphene nanoparticles under this family is graphene oxide. Nowadays, many of the researchers change their research area from graphene oxide to amexin, because amexin is right now giving a good results in terms of water purification. But as far as the CO2 separation is concerned, still very few researchers are working in the area of amexin, and that's why we decided to compare, because we have already done lots of work in the area of graphene oxide for CO2 separation, or we have already done some work to generate to develop some nanofluids and identify their application for CO2. But we are now emerging into some more area, that is amexin, and we are trying to synthesize advanced material like amexin material, which gives us a good CO2 separation efficiency. Then 2D colonies, here you can see these are different types of nanomaterials. Then you can say molybdenum, selenium, and then different types of compound which are really useful for semiconducting kind of properties. Then layered semiconductors. Here you can see the different material, bismuth based, gallium based, and then here you can say metallic dichlorohides, titanium sulfides, then other kind of things are there. So this kind of nanoparticles also created good impact for CO2 separation as well. And then 2D oxide, 2D oxide family, where titanium dioxide, MnO2, vanadium pentoxide, and the TiO3 and ruthenium based oxides, this kind of nanoparticles have some impacts. And then layered oxide, layer cuprous oxide, you can say perovskites type of, because nowadays, if you belong with the solar department, then many of the researchers are working in the area of perovskite, and they are identifying their applications in all way. And this is all about the nanomaterial family. Now, there is a basic difference between the graphene versus graphite, and that basic difference, because if you look into this graphene and graphite, graphene here, the bonding and the orbitals are really, really stronger. And that's why we have to go for the graphene and graphene based sheets. And this particular structure is really useful for separation of any kind of application, for any kind of separation. Okay, not simply for CO2, but for water purification or some other major applications as well. Wait a minute. Now here, if you look into this slide gives you the idea about how we synthesize the different types of the nanoparticles, including the synthesis of graphene oxide. You can see here, this step 1, we have synthesized the graphene oxide. Step 2, with the support of the microwave synthesis of some compounds, we have done the synthesis of MOS2 and WS2, and then third one is the mixing and filtration stage, and then vacuum oven, and finally we are ready to prepare a modified film of the graphene oxide, or a bead a bead of the graphene oxide. And this particular film is applicable for CO2 separation. We are using, as of now, we have not used this particular film for the CO2 separation, but we are trying to utilize this graphene oxide modified sheet for CO2 separation. And these are the various nanomaterial syntheses, as I given you the idea about a single materials and then prepared material, binary nanocomposites, a ternary nanocomposite. Right now, we are doing some in connections with the Sunway University, Malaysia, and the Taylor's University, Malaysia, and University of Nottingham, Malaysia. With this university, we have a strong connections, and we are trying to develop some different types of advanced nanomaterials, advanced MXins to for separate applications. Let's say application in terms of oil industry or fuel industry, or applications for nano-based industries and other things. So here, these are the graphene oxide, metal oxides, and then carbides, and then binary nanocomposites. We are targeting the conducting polymeric kind of nanomaterials, where these are the various compounds: mixed metallic carbon-based compound, that is graphene oxide, carbon nanotubes, and porous biocharge. And ternary nanocomposite, these are the various mixed metallic carbonious and carbonious material. Okay, so this is a slide one slide which I have taken from Sunway University. You can see we are doing some collaborative work in connection with the Sunway, and you can see how we can prepare different types of nanomaterials with the support of the various processes like CVD and then PVD or sol gel and some other technique as well. And yes, this is recently, one of my research group means from one of my collaborators have already developed established a good setup for the MXin development. Now we are also targeting to develop some carbide based or some other kind of titanium based MXins, which having the capability to use for the water purification and the CO2 separation. And that's how we are targeting. As of now, we have not done any study into the MXin, but we are slowly emerging into the MXin kind of compound and try to do something in line with the CO2 capture. And these are some chemical structure and compositional diversity of the MXin. MXin applications. This is a one. This area is very good. I request some of you, if you guys are really would like to do some good research in terms of energy storage or energy conservation and the management, I think you can look into this parameter MXin. There are different class of the MXins. MX phase are there, and you can synthesize different types of different MXin compound, and each and every individual compound have different application like energy storage, catalysis, electronics application, environmental based application, sensors, biology. One of my colleague developed a biosensor with the use of the MXin, and that idea got published as well. So that's really, so this particular area is really emerging area to work on. Now, this is all about a nanoparticle. Now I just want to give you some glimpse about the nano research, how we can strengthen the, with the applications, with the use of the nano, how we can strengthen some area. So there are some areas, I just want to highlight some of the case studies, and some of you might be familiar with these case studies. As solar cell. Solar cell is a very common terminology, and but nowadays it's very popular. Okay, in almost in all Gujarat, we can see in many parts of Gujarat, the government established the solar panel, and I think this is a good choice to create the electricity, right? So solar cell is a device which converts solar energy directly to electricity using PV effect. Okay. So, but my idea is not, I don't want to discuss much about the solar cell because this is already established technique, but I just want to highlight something. The innovation is made to manufacture dye-sensitized solar cell which uses nanotechnology. Okay, my intention is to highlight the use of nano in dye-sensitized solar cell, because everybody knows the moment when someone established something, there might be certain limitation, that particular device has certain limitations. So in a similar way, the moment when first of all the solar cell has been designed, that time some limitations are there, and that limitations, researchers identify that limitations and they want to work on the modified solar cell. That's why they apply the concept of nanotechnology and modify solar cell in terms of DSSS or DSSC, dye-sensitized solar cell. Here you can see this is the working of dye-sensitized solar cell, where what they have done, they have modified the tubes. Whatever tubes are there in the solar panel, they have modified the tubes with titanium dioxide nanoparticles. So TiO2 nanotubes. And what is the advantage of this TiO2 nanotube? Which is excited electrons infused into the semiconducting TiO2, transported out of the cell. And based on that, the conversion of the energy, the whatever the energy that they are getting captured, that energy get captured in, with a more efficient way. That's why they have been attached the TiO2 nanotubes into the solar panel, and these are the Ti metal. The whatever platform you can see here, there is nothing but the titanium metal based platform. So light with high enough energy excites electron of di molecule. So this particular dye-sensitized or DSSC solar cell is able to excite the molecule, or excitation of the energy will be high, and we can able to store more amount of energy or electricity in lesser time. That's the beauty of this particular cell. You can see here, this is a regular solar and this is a nanocrystal based solar. You can see the radiation coming from the solar cell, to the solar panel, and only the conversion electric, you can able to save or store some amount of the energy. But if you look into the another side, this is DSSC, dye-sensitized solar cell. Here the you can convert the electricity, and you can store the electricity in shorter period of time with better effectiveness, right? And this is the most popular concept. This is the very new and very popular concept nowadays in most of the Western countries or the European part. Many sectors, you can see the plastic solar cell is most popular. Okay, and this you can see there are so many kind of advantage of this plastic solar cell, and why this plastic solar cell are really good in terms of in comparison with normal solar cell. They are 30% more efficient than the conventional solar cell. 30%. It's a high jump. 30% more efficient than the conventional solar cell. And conventional solar cell have bulky solar panel, while these are quite compact. See, if I kept this solar plastic solar cell, if I use as a roof, tomorrow if I decided to move this roof to some other place, I can easily disassemble this particular thing and easily take this roof.
Swapnil sir.
Yes.
Sorry. Yeah, if you want to take a break of a couple of minutes, because I think your throat is aching. I can feel that.
Yeah.
So,
okay, then just give me a minute only. Okay.
Yeah. You can have a some soothing drink.
Yeah. Just give me the minute. I just want to take a warm water. Okay. Just give me a minute.
Please.
Okay, thank you, Dr. Anurag. So, yeah, if we talk about the applications of this plastic solar cell, one important application is it's 30% more efficient than conventional solar cell, right? And one other part is that traditional solar cell, it is very, compact, very bulky. And if you look into this plastic solar cell, this is very, very, compact and easy to move anywhere, flexible, and have potential to turn solar power into clean, green, and consistent source of energy, right? So these are the advantage of this plastic solar cell. Even if you look into the roof of this car, if you place a plastic solar cell on the top roof of the car, it can even charge the batteries as well. So this innovation is nowadays very popular and very familiar. You guys are familiarized with this kind of innovations. And that's why, and there are lots of commercial examples. Many industries are using this particular techniques, and these all techniques established with support of the nanomaterial applications. And that's why if you work on the energy efficient nanoparticles or nanomaterials, then you can able to develop some good techniques which may have some commercial values. Now, if I talk about another case study, that is nanocatalysis. Okay. So as we all know, nanocatalysis, there are certain parameters where you can see, if you look into the improved economy and energy efficiency, reduced global warming, high activity and selectivity, safer catalyst and reagent, minimum chemical waste, easily separable, excellent stability, enhanced surface area. So these are certain parameters which is really required in current at current need of the time. And that's why if you use a nanoparticle as a catalyst, then they are having lots of application in the various diversified area. It's an environmental, you can work into the environmental productions, then photocatalytic activity, drug delivery, water purification, fuel cell application, solid rocket propellant, and biodiesel production, thin film solar cell. And these are the wide applications of nanocatalyst. But I'm just trying to highlight the application in terms of the biomass gasification. If you look into these biodiesel production, where mostly commonly used catalyst for biodiesel are calcium oxide, zinc oxide, alumina oxide, and MgO. Okay, so these are some nanoparticle which makes the process of biodiesel very, very effective. Because if I look into this one, a biodiesel is usually produced by transesterification reaction in the presence of catalyst. So use of conventional catalyst may incorporate the problem to comprise with the yield, quality, or the efficiency of process. There are so many catalysts we can use, but they all are normal catalysts, and they are having some problems in terms of yield, conversion, and that will affect the quality of the biodiesel, biofuel, and biodiesel. That's why the use of nanocatalysts, which have saved reaction time, which increase the rate of mixing, faster recovery of catalyst to give a better process. Okay, so that's why these are some nanoparticles or some nanocatalyst plays very important role and very, very useful to enhance to give you the good quality of the biodiesel with high activities and unique properties. So that's why there is application of nanocatalyst into the biodiesel production as well. And there are some studies, already some research have done some study in the field of nanocatalyst, where they identify calcium oxide catalyst with efficiency of 96.8%, and the based on the characteristics of the nanocatalyst, that means enhanced catalytic activity, stability, and more resistant to acid poisoning, gives you the good efficiency. But the most important catalyst to give you the good efficiency is zinc oxide. But if you compare ZrIO2 with calcium oxide in terms of cost, then this CaO will give you, let's say the cost, this CaO is very much cost effective. Okay, even though in terms of efficiency we are lagging only 1.2%, but we are not much concerned about it, because the value and the cost of CaO is less as compared to ZrIO2. That's why we can go ahead with this calcium oxide or titanium based oxide kind of nanoparticles, specifically for biodiesel production. These are the recent innovation. One of the recent innovation is the use of nanocatalyst having the magnetic property. So this property eases the separation of nanocatalyst in the presence of external magnetic field with minimum loss. So if we want to do a better conversion or better purification of the biodiesel, then you can go for metal based nanoparticles, which enhance the separation, and which easily give the separation of the biodiesel and all. These are the commercial applications of these nanomaterials, which offers many possibility as catalysts to meet future demands in the following technology. That means petroleum refining, petrochemical industry, synthetic fuel, polymer, pharmaceutical, food. Everywhere there's a huge demand of nanomaterials and these various processes. I don't want to highlight much about nanotechnology in water treatment. You can see there are various sectors, and I think many of you are familiar with this scenario, what techniques are really good for water purification. But I just want to highlight one thing here. Everybody looking for a requirement of stable, more economical, effective, and reliable method, which is really the need increasing day by day. And whenever we go for any research, these parameters comes into the play, and we are more focused on these few parameters. And that's why before picking any topic for research or any topic for actual implementation, we have to always go for look into their effectiveness, their performance, and other things. So we require highly efficient, modular, and multifunctional process to provide high performance and affordable environmental sustainable process or wastewater treatment process. So here there are different processes, out of which we can say nanosorption is the best one. And there are so many and so many nanoparticles which play very important role to purify the water. Here you can say graphene oxide, fluorine, nanodiamond, NPC, then carbon nanotubes, and top side you can see you can able to remove the various compounds. One of my research group is working in the area of the development of the advanced material for the emerging pollutant removal, where we are targeting the various kinds of heavy metal like mercury, then cadmium, arsenic, chromium. Recently, one of my PhD scholars, PG student published her research work into the Journal of Molecular Liquid that is completely based on the chromium CRVI compound. Okay, and she had synthesized the chitosan based nanoadsorbent and the flames and identify their application for the chromium removal. So there are certain parameters: higher selectivity, enhanced surface chemistry, and if we look into the adsorbent, non-adsorbent, these are some names like metal-based nanoadsorbent, bioadsorbent, and carbon nanotubes, including graphene oxide. This gives you the good result in terms of removal of these particular compounds from the waters. Okay. I just want to skip out certain slides. Yeah.
Yes, sir.
Yeah. So this is zeolite. This is one kind of MOF structure, metal organic framework, which is also applicable for CO2 separation. Recently, we have synthesized ZIP67 kind of framework, which is really efficient for CO2 separation. And there are certain barriers when we go for this kind of techniques. There are certain barriers which are really matters a lot. That is cost of nanoparticle, or some nanoparticles are really high in terms of synthesis, high cost. Some of the nanoparticles are toxic, and some nanoparticles have potential human health hazards and risk. That's why. Okay, so I don't want to. There are some of my research work. I don't want to highlight that work much here. I'm just trying to give you the idea about one final emerging technique, that is, yeah. So this is the third point. First, we had a discussion on CO2, then we had a discussion on nanomaterial research. Now I'm just trying to give you some glimpse about how the techniques of ionic liquid for cleaner fuel production is really serve the purpose to sustain the environmental problems. And see, we have filed couple of patents. We published lots of papers in the area of desulfurization processes, and one of research scholars is still working on the product, the minimization of sulfur from the fuel. So here, if you talk about the need of this study, as we all know, BS4 emission standards, if you look into BS4, the sulfur range was different, but currently we are running with BS6. Okay, so all of a sudden the requirement of the sulfur was drastically changed. Now we don't require sulfur more than 5 ppm in actual fuel, and we are able to achieve that also in BS6. Okay, and that was ultimate aim of our study when we picked this particular topic in the year of 17 somewhere. And the BS6 fuel contains 10 ppm of sulfur, while BS4 fuel is 50 parts per million. Okay, and then BS6 will be applicable vehicle having a total weight less than 3500 kg, and which will be manufactured on or after 1st April 2020. So this particular figure we have kept with support of this published news. And then we decided to go for desulfurization process, and I just want to highlight few facts about desulfurization. Some of you might be aware about that, why we need to go for sulfur free fuel. Only the important parameter is we have to minimize the environmental pollution load in terms of SOx and NOx, and that's why many of the countries earlier, during BS4, they make the things mandatory to have the sulfur free less than 10 ppm. Okay, that means we can consider this fuel as a clean fuel. Otherwise, earlier there was a percentage of 50 ppm or 180 ppm present in the sulfur in fuel, and that cause major problem in terms of environmental issues and all. That's why the BS6 norms are applicable now on. Then we decided to go for sulfur removal based on the various studies. And one of our research group is actively involved on sulfur recovery. We are targeting, let's say, as I mentioned you, we are having a strong relationship with the Apar Industry Limited. Then this time we are working on the base oil. Okay, earlier we were working on gasoline, diesel, and some other kind of real fuels. But as per the BS6 norms are concerned, that particular fuel don't have the sulfur content more than 10 ppm. Then we are not working on that. Now we are working on the industrial based fuel where the sulfur content more than 3000, 4000, and we are trying to identifying the best suitable solvent to minimize the sulfur from their base oil and their fuel. So there are different methods. Here you can see this comes in the category of desulfurization, but specifically we targeted on ultrasound, membrane, and extractive. Okay, extractive. I have done research in the field of extractive, but one of my research scholars is doing research in oxidative and ultrasound assisted desulfurization process. So basically there are certain parameters which makes this process very effective, and as we all know, basically the extractant, whatever solvent or whatever extractant we are preferring, that may have certain attributes, and that attribute need to follow. That is good extractive stability, free of contamination, non-toxicity, and stability for repeated use. Now there are different types of ionic liquid, as I given you the idea about earlier as well during the CO2 study: imidazolium, pyridium, phosphonium, ammonium, sulfonium. I don't want to prefer these two compounds because of their regeneration issue, because of their extracting capability. Then we don't want to go for ammonium and sulfonium. We always target imidazolium because it's a very easy to prepare and very less in cost, or very cost effective. Pyridium, again, but as far as phosphonium is concerned, the development or synthesis of phosphonium is little bit difficult, but in terms of effectiveness, if we talk about this phosphonium ionic liquid, is really having a good impact in comparison with all these other ionic liquids. Okay, so if we talk about the applications of the ionic liquids, if we talk about the application part, there are various applications including all sectors, and we specifically targeted on synthesis and multiphasic reactions and extractions. That is this particular region where we targeted the applications of the ionic liquids. And then we have done a lot of extensive literature survey for that, and we identify the best possible compound. These are the various compound present in fuel. These are the various aromatics, the various form of the sulfur compound which are present in fuel, including thiophene and 3-methylthiophene, then benzothiophene, dibenzothiophene, and other compounds. These are the alkyl substituted derivative which is present in fuel and very difficult to remove from the fuel with normal processes. Still, many petroleum refineries, many industries, they are preferring hydrodesulfurization process. Again, still they follow the same procedure as usual. But the major disadvantage of that process is that process required high amount of hydrogen as a catalyst, and tremendous amount, they required high amount of high temperature and other things. But as far as if we go for extractive or oxidative process, in this process we don't require any additional catalyst or any high temperature requirement. You can run this process even at room temperature as well. So here you can see there are some processes, and we have already highlighted all the do's and don'ts of the processes. SDS technique, high temperature and pressure required, difficult to removal of aromatic sulfur content. Whatever sulfur derivatives I have shown you, that is very difficult to remove out from SDS process. SDS process could able to remove the sulfur up to 250 ppm, not below than that. But extractive and few other techniques are applicable to minimize the sulfur limit below 10 ppm as well. That's why these techniques are most popular. And even though in comparison to ultrasound means what? Even though we are trying to prefer ultrasound, but still we need to take a follow-up of extractive. First we have to go with ADS, and then you need to provide ultrasound. So in my view, extractive desulfurization process is the most efficient process, because in a single stage operation, this process gives you around 78 to 80% separation. And the moment when you attach ultrasound, then you can increase that separation, let's say plus 10%. So many industries, they don't want to prefer ultrasound. They simply think, be in comparison with SDS, if they are getting 70%, then they can think about EDS process, since they are getting up to 80-85% sulfur removal. And these are the various routes of the ionic liquid synthesis, where you can see how we can synthesize the ionic liquids, the metathesis reactions, acid-base reactions, direct combination of halides and salts with metal halides. So we can easily synthesize imidazolium-based ionic liquids, but for phosphonium-based ionic liquids, you do require special requirement. You have to provide inert gas and other things. You have to keep that batch under inert atmosphere. Then only the synthesis of phosphonium-based ionic liquids will be possible. Otherwise, you cannot synthesize the phosphonium-based ionic liquids. These are the property, as I already discussed earlier. And this is the possible mechanism of both the processes, EDS and ODS. And these two processes are really promising for sulfur recovery from the from the fuel stream and all. And you can able to recycle this particular you can able to recycle these ionic liquids for multiple cycle. As far as my study and our study is concerned, we can able to recycle this ionic liquid up to 10 to 15 times, specifically in the case of EDS. But as far as ODS is concerned, means oxidative desulfurization process is concerned, here we can use or recycle this particular compound up to 6 to 7 times, not more than that. And later on, it gets saturated, and you cannot use that compound. You need to use a fresh ionic liquid for the continuation of your process. So this is all about the various processes and the various insight on the various processes, energy efficient suppression processes, specifically for environmental sustainability. And I strongly acknowledge the DST, specifically because they fund us a very huge amount. They given us two different mega project. One given by DBT, almost 75 lakhs, and another project we have received from DST. It's up to 60 lakhs. So we are working because of this COVID, we got stuck somewhere, but still we are trying to produce a good set of the results for the for commercialize some technology and for the betterment of the industry and other things. And this is our current research group. This is my research group, basically along with Dr. Manish and Dr. Dash. We three are working. Dr. Manish is expert in the field of membrane separation, and Dr. Dash is expert in the field of CO2 capture, not utilization and separation. And this is the team. You can see three PhD scholars and one JRF. And so this is all about for today's talk. If you have any doubts and if you have any questions, feel free to ask me. And I also mentioned one thing. If you want to collaborate something with our institute, feel free to collaborate with us. We are very happy to give you all sort of support from our end. And you can utilize the infrastructure facility of the PTPU in just collaboration with department or the institutes. Thank you.
Yeah, thanks a lot, sir. Thank you very much. And we will definitely, if anyone, one of us is interested, any participant who is interested, the School of Technology is ever willing to collaborate with you and guide you.
Yes.
So there are a couple of questions.
Wait a minute. Yeah, please.
One of the question is from Professor R.B. Varia, sir.
Yeah.
That is energy required to overcome pressure drop, right, due to membrane in the system is how much, and does it depend upon the type of membrane?
Yes. Yeah. Basically, it depends on the type of membrane. If we go for highly dense membrane, okay. Sometimes what happens, it depends on the porosity, it depends on basically, if we look into the actual requirement of the membrane, we do require high chemical potential, okay. So in our case, we are trying to target on the flat sheet membranes only, because on flat sheet membrane we can easily encapsulate ionic liquids. If we go for a hollow fiber or a tubular based membrane, the encapsulation of the ionic liquid support may not be possible. And in our case, membrane only can withstand the pressure. If I use the membrane alone, it can only withstand the pressure up to 3 bar. But the moment when I give the support of the ionic liquid, that to phosphonium based ionic liquid, so that particular support enhance the efficiency, or enhance the the withstand capacity, pressure capacity of the membrane. That's why we can able to withstand that. We can use that membrane up to 5 to 7 bars. And as far as energy intensity is required, as of now, we have not done the calculations, but sincerely speaking, temperature variation, because DST asked me about the temperature effect, we can use this particular membrane entire for, even for an entire day without happening any breakage. But supports are required. There are different types of supports: PVDF, PTFE, PSE. We do prefer which support is really applicable or compatible with the ionic liquids. Based on that, you can identify the best energy efficient membrane for the process.
Yeah, probably that was probably the next question. I think you have answered. Same, sir. Like Professor Alvi Padya was asking that which type of membrane is energy efficient till today.
Right. See, if you because nowadays, if you look into some, most of the research is going on into the IIT Guwahati, IIT Bombay, and IIT Kanpur and Kharagpur as well. So when I interacted with Professor Vishnupada Mandal, that time he mentioned me, Swapnil, if you preferred a PTFE support, okay, PTFE support, that is really good for withstanding the high pressure. At the current moment, we are preferring PVDF with addition of the ionic liquid, as I mentioned, imidazolium and the phosphonium. But PTFE support will give you more separation and withstand a good pressure of the gas and all. So as far as industry is concerned, I think PTFE is mostly preferable membrane for withstanding the high pressure.
And so there's one more question from Professor Santosh Vyas. How much scope in doing research work in controlling carbon dioxide emission with the application of suitable vegetation?
Application of what? Suitable?
Suitable vegetation.
Vegetation, okay. So if I say about the scope, lots of researchers are working in the field of CO2 nowadays. If you go for any research, you can get you can identify lots of paper already got published. Let's say take an example of biofuel. Still the people are working in the field of biofuel, and they got filed their patents in a very effective way, even though a few years back, some researcher mentioned the scope of biofuel is very limited. Still, they are able to publish the research. They are getting a good opportunity in the PDF also. So as of now, we cannot predict the scope. But sincerely speaking, at the current scenario, climate change and the global warming is the major cause. And because of the industrialization, globalization, I think CO2 emission is the capturing of CO2 is play very important role, and that's why the research, if you guys are really working on CO2 separation or CO2 emission controlling, that create a good impact for your future progress.
Well, thank you very much, sir. Is there any more questions and any more queries? Any participants who wish to ask any questions to Swapnil sir? Feel free to unmute yourself and you can ask your questions. Okay, I guess there are no questions, sir. So
yeah.
I sincerely, wholeheartedly thank you, sir, first of all, for accepting our invitation and being our expert for this particular session. And you have covered many areas related to carbon capture. And I think your knowledge and whatever you have shared with us will definitely help us or the researcher in us. Sure. And we will, or some of us definitely will work in this research area in near future. So I thank you once again on behalf of the organizing team and on behalf of all the participants. I extend my heartfelt thanks to you, sir. Thank you, sir.
So thank you all, and I hope I covered all the aspects. And sometime because of let's say other commitment, we could not able to cover up all the spectrum. But I hope I covered as per the requirement of the workshop. I covered few important topics in relation with the energy conservation, energy and energy
Yes.
management. Yeah. Okay. Thanks a
Sir.
lot,
Thanks a lot, sir.
and have a good day.
Yeah.
Stay safe.
Yeah.
Thank you.
Yes.
Yeah.
Participants are requested to stay in the group, please. Don't leave as it. Please stay in the group. Yeah, dear participants, few important announcements that needs to be made. The test link, as you were told by the coordinator, Dr. R.D. Patel, sir, that there will be tests every day, right? So the test link will be shared in the WhatsApp group, and you are supposed to complete that test by tomorrow morning. So please make sure that you submit the test before time. Hope you all must have filled your attendance. And from tomorrow onwards, our morning session will be from 10:15 onwards. So all are requested to join the session before 10:15 a.m. and we will start the session latest by 10:20. Right. So we sincerely hope and request you for your cooperation and to attend all the sessions and take maximum benefits from this training program. The training team, the organizing team has worked really very hard in bringing in all the experts from all different aspects in energy conservation and energy management, as well as there are a lot of case studies that we have put up in this particular training program, which will definitely help you in your research work as well as in day-to-day affairs. So please make sure that you attend all the sessions. And as I told you that tomorrow at 10:15 a.m., please join the Google Meet before 10:15 a.m. and we will start the session by 10:20. Thanks a lot. R.D. Patel, sir, would you like to say something? Yeah, thanks a lot. Thanks, everyone. See you all tomorrow.